Hi, this is Faxi Nadu. Welcome back. In the last video, we've taken a look at sequencing when we built the drum machine, and we've shown how you can sync the sequencer to your external DAW, among other things that we've shown. We're going to show some more things about sequencing in this one, and we're going to also be building a kick drum synthesizer, and we're going to show how you can do that sequencing. So I've already taken out, before we started, just the basic things, multi-effects, and this will be our output. And then we have the MVC, which will be our MIDI brain, and we'll connect it to the incoming MIDI that is incoming into the patch. And we also have a MIDI clock, which is I've already connected the clock to the clock divider ready beforehand. And the last time we've used the drum sequencer, and right now we're going to use a gate sequencer, and this is all the way over here in the gate folder, sec1. There's also a gate sec2. Let's see. If I'm not mistaken that it's either like a gate. Is it a gate hold or is it let's see, gate sec1 2. I thought sec2 is like note length, so it's extended note length on sec2, but we don't need that right now. For the kick synth, we're going to be using sequencer 1, sec1. Steps like the drum one, but like by default, they're all turned on. So let's turn them all off except four on the floor, kick, drum type sound. Just set it up on all these. Have to make the connection. So first of all, we're going to need the MIDI timing, MIDI clock, and we're going to set it to 1/16th node. So it's like a regular DAW set to regular time signature clock. And we're, instead of connecting it to the sequencer this time, we're going to do something else. We're going to have it's called a start stop button, and what it allows is to have an internally start and stop the sequencer. It also starts and stops the MIDI clock. We've connected it to the start stop, and it's also connected to the reset button of the sequencer itself. So when it's playing, if we press one time play, it'll start playing. If we press stop one time, so okay, yeah, it's just, I thought it was two clicks, but it's just one click. So if we press stop, it'll stop wherever it is. But if we play again, it'll also reset the sequencer. So we're going to be starting each time. This option, we could just go with this. But then I thought, like, the reason why I wanted to have both things, and I'll show you just in a minute, is that I thought that, like, have a kick synthesizer that you can also use it to just kind of like sample kicks, or in a performance situation, but also to just sample kicks without a DAW. So just like open this patch and tweak away on kicks and record it like into a wave editor. So you need something to trigger the kicks, so you have an internal sequencer. But I also wanted to act like a normal synth where you can play MIDI notes, and those MIDI notes will trigger the kick. So you can just like actually use it like any plugin, like a kick synth inside your DAW. So this is not our machine. This is another machine that I've opened, but just for the example. So make it so you can play notes on your MIDI keyboard and it'll play kicks. That we're going to also need to involve the MVC, the MIDI brain, and the incoming MIDI information, that is the gates that are incoming. Brain will take these gates and separate the information, like and it'll output them on this knob, on this gate out. Sorry, connection, not knob. And we have this. So this by itself is not enough to trigger anything. You need an envelope. Take out an AD envelope. And now we can actually trigger things because we're going to connect the gate to the envelope. And now whenever there's a gate message received, this envelope will trigger and do its thing. And now we have an actual control signal that we can use in the patch. And we can use this to control volume and pitch and the rest of the things that we're going to be needing in this patch. So we have a control signal, but we don't have a sound source. So the simplest way to synthesize a kick drum would be to just use a sine wave, and we're going to do that. So we're taking a sine oscillator right here. And we, of course, need a VCA module, an amplifier for our patch. This first envelope that we have right here, let's use that for the volume. This will be right here, the volume of the VCA. Then we're going to connect the output of the sine, this oscillator, into VCA, and we're going to go to the output. Connect it like this. Not going to hear anything because the sine has no incoming frequency information. The sine at what frequency it is, so it's not oscillating. It's not spinning on any frequency. This being a kick drum, instead of controlling the actual note via MIDI, start with a constant, with like a stable frequency, a stable sine at one frequency, and modulate that to our liking. So what we need for this, constant frequency module, so we can just set that we want and output it to the sine oscillator for something like 50 hertz. See well for a kick. What we have right now. It, put a little bit of volume, and press. Obviously, there's nothing going on because nothing is triggering the envelope until I press play. So I'm pressing play. And we have a short sine that is playing. So it already kind of sounds like a kick, but we can do much more if we actually modulate this frequency and give it like, that's what a kick sounds like, right? It starts out with like a sharp sweep downwards. I'm going to simulate exactly that. So we're going to take a pitch modifier, take this constant frequency. Let's make a little room. And it's going to go to the pitch modifier and to the oscillator. And we're going to use envelope from the sequencer at the moment. And this envelope is going to modulate the. So let's see what we have now. So it's really a mellow effect. If we turn it off all the way, so it is giving it some punch. But what if we would like more? Now you can do this stuff in various ways to multiply and give punch to the envelope. We're just going to do it in a way. We will send two envelopes to the pitch modifier, and this serves as kind of like a doubling effect. But we're going to have them on different settings. It's going to give us more control over the sound. So let's listen. And now while moving around these two envelopes, then we get a much more control, and we have much more. We can have like as steep or as a mellow pitch sweep as we would like. So it's much cooler. Now let's do another thing. We've used the linear VCA up till now, and use a exponential VCA. Same connections, input, and where was that? The envelope. Now the difference is that this VCA has a slope, so it actually kind of bends and gives them more of a curve. You can think of it as kind of like fading, and it's just more control over the shaping and tonality of our kick. Works really well here. The VCA inside adds a lot to our sound. We have everything going on as far as sound, and we also have the sequencer. But I mentioned before that we also want the ability to our board, then have that control the kick synth. So we're going to need to involve this, like we said, the MVC, and we're going to need a module that what it does is it knows that is triggering the envelopes. We want to have both at the same time. So we kind of want these inputs to listen, so to speak, and wait till they hear a gate signal. And that gate signal can come either from here or from here. Gate connections. Tool called gate OR. And it should be here. It's called gate logic. It has the OR inside. What it does is this. You connect two gate signals to it. And we have our two gate signals are the MVC and sir. It has and or XOR. Means that it will only play only output a gate signal when it's always listening. This module is always listening on the inputs for gates. While on and when there is a gate signal, when it hears a gate signal coming from here and coming from here. So if at the same time there is a hit here and something is coming from the sequencer that is here as well, then it will output a gate. So that is how the OR works. Outputs a gate all the time unless here's the gate on the same spot. So if you had like your DAW set up exactly like the same as this one with one on every one gate on every one beat, then it would play the opposite. It would play these three. Now the one we want is the OR because we want it to listen and decide that it is outputting a gate signal if it either hears a gate here or here. We set it up like this, we made the connections, and now we're connecting this gate logic module instead of going directly from our sequencer like it was before. So here we go. And the last one. And we made the connection. Now you notice this patch is monophonic, right? Because we're creating just one voice of a kick. So all the modules are switched to single mode, to monophonic mode, and they are green. And I did mention to you guys that you see this e-sync input here and on the envelopes and on the sequencer. It is used to manage voicing so that on polyphonic patches, all the envelopes will be synced and starting together. But this is a monophonic patch, so we're not even going to connect the e-sync. I must tell you that when you're not connecting the e-sync inputs, connected to anything, then this MVC doesn't work. Don't know if it's a bug or like a design designed on purpose this way, but the thing you need to do for this to work when not making eSync connections is it's called short circuiting the eSync, and you click here and just connect the eSync to the gate. And then it's short circuited and this module will be outputting even though there's no eSync. If you don't make this short circuit, this module is like not operating at all. So it wouldn't do anything and it wouldn't be sending gates to the gate logic signal. And now it does. So if I like, and that's working, and I'm going to press my keyboard, and it's working as well. So that's cool. So now this patch, if you open it standalone, just load up this patch. You can like a kick here, press play, tweak away and start recording kick drums and get yourself like edit them or whatever and make like a kick sample pack for yourself or for sale or whatever you want to do. Or alternatively, you can open your DAW and send MIDI from your DAW to the patch. Just send MIDI notes and use it as a kick synth inside your DAW. Another thing you can do, you don't need to, it's obviously I'm just showing you, obviously it's modular. Just add a filter in here. You could actually filter the sound if you want to. If you don't want to, you don't have to. And you can add as many envelopes, LFOs, and whatever you want. So and it's just a little bit even more tonal shaping. Oops. Okay, so that's your basic kick synth, and I'm glad that we had a chance to show this this gate logic module and the usage for it. There are other usages for it, for creating like random things in music, and we'll show a cool usage for it when we do the ambient drone super patch, kind of ambient live patch. But before we finish this, we've shown how to use the sine wave to create a kick. But let's also look at just one more method really quickly. So instead of the sine wave, let's delete the sine wave. Take let's take just this filter, and you notice it's called the 24 dB low pass R, which means it is self-resonating. So if we turn it all the way up, it'll self-resonate. Self-resonate if there's absolutely no input. So we're going to have to send something. Oops, connections for a minute. We're going to have to send something into this to trigger the resonance. So what we're going to use is like the shortest possible, a short noise burst. Use a noise exciter inside, but just for the example, we're closing everything. It's not outputting, it's outputting just like a click, just a small click. 8, just real quickly. And let's put it like, it's like outputting a 24,000 hertz, like a 24K sound, but it's actually not gonna, you're not gonna hear that sound because it's just like the shortest click ever. And it's not playing anything now because it's not even resonating. And here we go. This is now the noise exciter. So the parameters don't matter that much. What is actually influencing everything is the resonance. So basically, it's not as stable as the sine wave, but it's very similar. You can do the same trick with the 2 envelopes and send 2 envelopes to this. So it is very fiddly. It takes a while to reach a sweet spot, but I have reached some sweet spots, and you can get really nice kicks from this design. I do want to go before we finish. Should have shown this before, but I remembered something important and cool that I wanted to show you. When we had the sine OSC re-triggered, and you're having like a really short envelope on it, and it's really hard to actually notice this through the team viewer. So I'm just going to explain it. Um, every single hit has a little bit of a different sound, just a tiny bit, because the OSC is not retriggering. So it has a little bit of a different snap and a different kind of tonality from hit to hit, just a tiny, tiny little bit. And sometimes you might want that because it sounds kind of analog that way. But if you don't want that, there's a workaround to that as well. So instead of using the sine OSC, the regular sine OSC, sine OSC sync slave, syncopal oscillator. So let's think about it for a minute. What is actually bothering us with this one, and what do we want to achieve with this one? The problem with this one is that while it's still in the middle of the cycle, when you hit, the value is like it's not smooth from hit to hit, and it's not retriggering from hit to hit. So it could be one hit could be starting on the top of the sine, and then one hit could be starting in the middle and on the bottom, and it will just be different from hit to hit. And this is what's causing this variation. Again, you might want this variation, but if you don't want it, the sync OSC, the sync sine OSC, sync input to actually reset the oscillator every time we start a new kick. The sync input is an audio input, and it's normally used to sync to another oscillator. So what is our option over here? First of all, let's take the constant back out just so you can see again like the right structuring. So I'm really quickly just taking the constant and the pitch modifier. So it was like this, just like normal connection, and we had the envelopes, right? So here's our sync input, and what we need is a module called gate to sync. It takes a gate signal to a sync signal, which is like just a frequency, like a reset signal. And we're going to connect it inside into the sync input. Now all you got to do is there's an on and off. We have OSC retrigger now. As simple as that. All you need to do to turn any OSC into a retriggerable OSC. And most of these over here there's the option for, like, every oscillator has a sync. So you can do it with any OSC, including the multi-oscillators. So the retriggered oscillators. Inside scope, there are other oscillators in Flexor, and we will see them in upcoming movies where you have already the retriggering mechanism inside. So I hope you learned a little bit about the gate logic, about the gate sync, how to build a kick synth with a sine, how to do it with a low-pass filter, and a little bit more how to use the sequencer modules. So stay tuned for the next movies and have a good one. See you soon.